Good afternoon. Today we're going to start talking about chemical reactions. So we don't have a lot of notes, but we need to make sure that we set the table for how to predict and starting to see how we can figure out what is being made, or if we know what was made, what it was made from. So that's kind of what we're starting with today. We have a lab on Friday that you get to do a lot of chemistry on your own. You get to do some real cool tests. Today I'm going to do about 3 demos, and I'm going to show you how you're going to kind of fill out your stuff. So I'm going to do exactly what you were going to be doing or are going to be doing on Friday. Okay, so hopefully you're with me on this. If we are, we'll have enough time to see all the things that we have planned for today. Okay, a couple quick things. Whoops. Just as a reminder, balancing equations, that's due by the end of the day today. You were given another sheet as well, equations 1. That's all we're working on tomorrow. So if you aren't completely done with that, working on it tonight, or if you've already been working on it, you still have a little bit of time as well for tomorrow. I gave you another sheet today. There's only one side. You don't have to slowly tip it over and scare the other side. And there's only one side to it. It's not due until Monday. So we're giving you a little heads or a little time in advance, a little heads up to give you the ability to maybe finish that early as well. And lastly, there's an extra credit thing that we'll talk about that you can do that's due by this Friday, and a lot of you will take advantage of it, I hope. So we are going to start right away. When we are doing reactions, we talked about this at the beginning of the year. What is a chemical reaction, what isn't? Well, we need to be more specific. When I'm looking at a reaction, I need to make observations, or I need to know if something actually was created. So there are 4 signs of a chemical reaction. I have images, and then I have actual like little mini videos of each. So first, if there is a color change, and these are things that we will be looking for from you when you have to make an observation. So if any of these happen, they don't all have to happen. If 1, 2, 3, or all 4, that's great, but only one of these has to happen to be considered a chemical reaction, meaning something new was made. So if a chemical reaction occurs, a color change might happen. That doesn't mean if you're playing with your Crayola crayons and you're coloring something green that you just made a chemical reaction. The paper was yet white still, the crayon is still green, they're just sitting on top of each other. Unless if the paper itself or the crayon itself change colors, that's not a chemical reaction. So the substance itself has to change. Okay? Bubbles or gas, if it's done in a solution, that's real easy to see because bubbles will rise and you'll see that easily. Otherwise, you might actually see gas emanating from the top or from the beaker or the flask. That's evidence of a chemical reaction. So great, super. The one we all love, 4th of July comes around and we blow up a piece of earth. Light or heat. Usually we see they kind of go hand in hand, not always though. Sometimes we kind of think of it maybe as change in temperature. If you feel a flask or a beaker and it's hotter, excuse me, or colder, then a chemical reaction is also happening. My hand warmers when I'm at a Packer game, chemical reaction, definitely. Those 3 usually make a lot of sense, and you've heard of them and you've experienced them. The last one, probably don't experience this as much. We're going to go through it quite a bit though. When a solid forms out of nothing, Mr. Blackford's going to do a really sweet demo next week where he will pour some liquids together and you will see something similar. But it's hard to believe when you see the picture. When you actually see it, it's pretty amazing. It's called a precipitate or precipitation. I'm not talking about someone working on a weather station. Oh, the 30% chance of precipitation. It doesn't mean rain. It means when a solid shows up out of nowhere. So you pour 2 liquids together and there's a solid. It can be yellow, it can be white, it can be blue, it can be red, brown. So those are all the kind of colors that usually result in a new compound's actually forming. That's something different than that was in here or in there, and we'll kind of discuss that today. Okay, so those are the 4. If you don't have it all written down, they'll pop up again. Here are some just images of these put to life, I guess. The upper left one, you actually did this in the either or lab. You put a bunch of aluminum into your copper solution before you left for the weekend. And when you came back, you had a big thing of like furry copper. Well, that's what's happening. That's just at a really fast pace. This is pretty sweet. This is called nitrogen triiodide. It's a contact explosive. If you decide or are interested in taking AP chemistry, every year I have some group that does that as their final project. It's so sensitive that if a fly lands on it when it's dry, it'll explode. And we always have some accidents where it's sitting in the hood and someone will bump the hood. I had a student one time just stretch. They were in the back row and they accidentally bumped the hood and it had dried enough and the whole thing exploded. Not the hood, but the demo. And it freaks you out. It's loud. And they had it triple layered, so they had 3 of them on top of each other. So when you hit the bottom one, boom, 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 they all go. So that's all sorts of gas that's coming off. Heater light, obviously anything with fire, anything with flames, there's a lot of energy coming off, and you can see it as heat and light. And then the last one is called a precipitate. Again, you take 2 like colorless liquids, and when you combine them, you will actually create a new solid that comes out of nowhere. Okay, so those are the 4 signs of chemical reaction, and we're going to be applying those during the demos today. Okay, so sometimes you got to have a little immaturity. Don't write this down. You can also remember it as farts. Don't take a picture, Evan. Come on. What happens in LGI 2 stays in LGI 2. No, I saw this online. I'm like, I got to put this on here. I want to remember this way. We'll just keep remembering color change, gas, heater light, or precipitate. But this is, it fizzes, aroma, if there's a replacement, if there's a temperature, if there's a new substance. Couldn't help myself. So there we go. Okay, so I'm going to set the stage with one of my favorite cartoons when I was a kid. And this is what made me so strong and healthy as well. I had Flintstone gummies for my vitamin. This is the intro and the closing song of the Flintstones, and then we'll get into types of reactions. So sit back and enjoy a little TV history.
Flintstones, they're the Flintstone family. From the town of Bedrock, they're a page right out of history. Let's ride with the family down the street, through the courtesy of Winston Pete. When you're with the Flintstones, have a yabba dabba do time, a dabba do time, we'll have a gay old time.
Now you gotta leave the movie theater. You gotta have a snack.
Flintstones, meet the Flintstones, they're the modern Sony family. From the town of Bedrock, they're a page right out of
Brontosaurus steak right there for you.
someday, maybe Fred will win the fight. Then that cat will stay up for the night. When you're with the Flintstones, have a yabba dabba do time, a dabba do time, we'll have a gay old time.
Turn can. All right. So, if you have your tablets, then you'll see why I'm using these images. If you don't, if you're just writing in a notebook, don't worry about the first images. I do have actual examples with the names. So we're going to learn 5 types of reactions today. The reason why we have to learn them is if we can understand the anatomy and how it's kind of constructed, like, oh, hey, that looks kind of like the beginning of that one, or that's the ending of that other one, we can make a lot of easier predictions. Okay? So, let me tell you a little story. Maybe I can make a little soap opera out of this. Anybody know who that is? Barney Rubble. Yes, that's Fred's right-hand man, his best friend. I think Fred takes advantage of him a little bit, but that's okay. This is his lovely wife, Betty Rubble. And you can feel the chemistry. It was love at first sight. And they became one. And anybody know their child's name? Bam Bam. But Bam Bam's not in this picture yet. So, when you have 2 compounds, 2 things, and you create one, you are producing something. Like in industry, you are synthesizing it. So a type of reaction, this is what for Shirley, even if you don't have the notes, the type of reaction this would be called is synthesis. Some people call it combination, but that's not really the name of it, it's synthesis. So I have examples for each of these, and real common everyday examples, which hopefully kind of allow you to grasp onto this a little bit better. So one that causes billions of dollars of damage is rust. And rust, you have iron, and there's more to this, but this is the heart of the reaction. You got iron, and you got oxygen, and it makes iron 3 oxide. So that's an example of, oh, sorry. I'll come back to it in just a second. But every time we have a reaction, we have to make sure it's still balanced. And that's what we're starting to work on. that balancing equation sheet that you're working on right now, those have some of the harder problems that we could give you. You'll start sensing and seeing that a lot of these reactions don't need a lot of effort to balance. So like, oh my gosh, it's just that, and I put a 2 there and a 3 there, and I'm done. Yeah, that is right. So if you can do the hard ones, you're going to eventually, or especially, be able to do the easier ones. So I look at something like this, and I see I have an FE, and there's 2 FEs here, and there's 2 O's and 3 O's. I'm not going to write everything on the bottom. Here's my trick. I see 2's and 3's. What do we talk about? 2's and 3's make 6. So as long as I can make them 6, so I want to put a 2 in front of that one to make 6 O's. I want to put a 3 in front of O2. And then what do I need in front of my iron? Now, I need a 4. It's okay to say it. If you know it, it's good. It's a 4, right? Because I have 2 times 2. So I have 4 FEs. So that is an example of a synthesis reaction, though. I'm taking 2 separate items, elements, compounds, whatever, and I'm creating one. Okay? So that's really important. So if I ever said like the synthesis of iron 3 oxide, oh, that means it came from its elements in the beginning. As just one example. Okay? So synthesis, that's 1 of 5. Well, in every relationship, things get difficult. Relationships are hard. You got to make sure that you're listening. And sometimes, you know what? You can't change them. They are who they are. They're going to do what they do, either side. So sometimes you got to have a break. So they went along their merry way, although they still look like they're happy, so maybe this is a good thing. So if you start with one kind of a compound and only one, and you break it down, you are breaking it into multiple elements or compounds, like a tree in the woods, or a body in your trunk, or mushrooms in the forest. They're all breaking down slowly. And what's happening is that they are decomposing, or decomposition. That is the second type of reaction. So, one I wanted to use for that, I think is a good example, is an airbag. Now, an airbag has about 3 reactions to it. It's not just one. But it starts with NaN3. I think it's pronounced sodium azide or azide. I think it's azide. And it breaks down into its elements. So you got Na and you got N3, and now you have Na and N2. So decomposition's breaking down. Once again, we got a balance. Very similar to the last one. I have 2's and 3's. 2's and 3's make 6. So if I make them equal 6, I clean up the mess at the end. So I have 2 Na sitting right there. I only have 1 Na. So I need to put another 2. And that's a balanced decomposition reaction. All right. But life gets tricky. Sometimes people's eyes wander. And they're neighbors to a very talented and smart woman named Wilma Flintstone and her husband Fred. So, although everything might be good, Wilma Flintstone might catch the eye of one Barney Rubble. And Barney might want to buy her some flowers. It's going to upset someone pretty bad. Homewrecker. She's a little upset. So this is where you see that you started with one thing where it was paired up. So you have a pairing, and I'll show you the actual chemical example in a second. And then you have one by itself, and what happened is that something in the pair gets kicked out, and the one by itself comes back in. So this is, a lot of people call this like the dancing couple reaction. So you have someone dancing, and then someone else wants to cut in. All right. But see, then all eyes now my eyes, I cannot unsee things. I just think about chaperoning prom over the last couple of years, and I have to talk about it. Ladies, you make it too easy for the guys because they have no rhythm, and you let them still dance with you. All right, guys, I'm sorry, I'm breaking your secret right now. I see the guys dance, so they're going out of rhythm. Let's just do this once. And all of a sudden the dance slows down to like 1/4 of that. Guys still doing this. Oh, it's a really fast dance. Guys are going like this, back and forth, back and forth. They're talking to everybody. Goes to a slow dance. Guys still going. And the girls are like, no, I'm going to go. Just let you do it. Because you're all talking to each other anyway. You're just talking to each other. That's all you're doing. I don't even think you know what they're doing. You don't know the pace. If you actually turned around and saw how bad the rhythm is, you'd be so embarrassed that they were dancing with you. So, if a guy actually could have some rhythm, they would come in and kick out the guy who just apparently thinks they just go as fast as they can until they're too tired. And they would kick out the one that can't dance, and then you could actually dance with someone who had some rhythm. So, I'm just saying, truth. I'm out. All right. That's called a single replacement reaction. See, the awkward silence is because they know I'm saying it. You guys know I'm saying it. It's real there. 3 years ago at prom, I saw a guy almost pass out, and it was a slow dance. I am not kidding. And the date's just like talking to her friends, like, hey, how's it going? That's pretty good. I'm like, do you know what's happening over here? Here's my example. This is cool. If you take AP Chem, this could be your final project. It's called a thermite reaction. There have been disasters in high schools with this because certain chemistry teachers will do it, and they won't have a bucket of sand, or they'll miss it. And it's so hot, you make molten iron, that it will actually go through the table, through the floor, to the next floor below you. So someone will be like doing work, and molten lava is actually, molten iron is actually dripping down on like their desk. Hopefully, not on them. So you got to do this stuff outside. They actually use it to weld and secure railroad tracks. Excuse me. So here is my example for you. Notice the Fe and the O are together. Al's by itself. Al's like, hey, Fe, you got no rhythm. So Al comes and kicks Fe out. Al's in, Fe's out. That's a single replacement. You have a group, and I need you to recognize this. There's a pair, and then something by itself. And now you have something, and it doesn't have to be written like this. I could flip these. My gosh, A plus B and B plus A equal the same thing. So I need to balance it. The O's look exactly the same. I got three. So I have two ALs, and I have two FEs, so it just looks... Again, balancing is not going to be as tough as this first worksheet. That's on purpose. If you can do that, if you can dodge a wrench, you can dodge a ball. If you can balance those, you can balance anything. All right. Now, I did not plan this, but there's no way. This is where the story gets a little weird and confusing, and I didn't mean it like this. I envisioned just they're playing a cranium game, but you can interpret how you want. Let's just go. So now you got Fred, Barney, and Betty.
I wouldn't say.
You got Fred and Wilma.
White swap.
No, I'm thinking they're playing cranium, and now it's, hey, new teams. But all I heard is people whispering swingers, and I'm like, ugh. Swing dancers, yeah. But, we're just going to move forward. Clearly, though, there are two pairs, and they're switching. That's as much as I will say. Double replacement reaction. So instead of one thing switching places, there are two. Okay. Great example, Rolaids. Huge industry. A lot of acidic foods in our ulcers and acid reflux and heartburn and all that stuff. You can take this and it will try to neutralize your stomach acid. So that reaction looks something like this. Where, and suggestion, please write this. Like, here's my H and here's my Na. Like those are the ones that are switching places. I know they look like they're in the same spot, but they have new partners. And you could argue, well, the other thing switched. It doesn't matter. Like, they're with two new partners. So H was with Cl, now H is with CO3. Na was with CO3, now it's with Cl. So I take my stomach acid and I add my Rolaids, and what it does is it neutralizes it and makes, this will break down into water and carbon dioxide, and this will be a salt. So usually, actually, when someone takes something like that, they get a little gassy. They'll actually start to maybe burp because you're actually, like, making CO2 in your stomach. So, I mean, it's not going to sit in there. If it doesn't, then you have pain. Then you're going to get stomach pain because the gas is trapped. Again, balancing can be tricky, or you can just look at it and go, wait a minute. you just find something, by the way. If something doesn't jump out, I always look at something that's not H, C, and O. If there's something that's not H, C, or O in the equation, that's actually where my mind goes to first. So Na is something other than that, and so is Cl. Well, Cl looks balanced, Na does not. So if I put a 2 in front of that, now the Cl isn't balanced, so I go and I balance that. We keep talking about when you change one thing, go and change the same one on the other side. And what did I just do? I put a 2 in front of the H, which balances it all out. So that is a double replacement reaction. So you'll just see that there's pairs. So those 4 kind of all link together in the ideas of either we're making or we're breaking it. We're switching one thing or we're switching 2 things. The last type of reaction is just a little different. I think, to me, I hate the word, but it's the easiest because there's the least I have to memorize because it's always the same. And that's this. You can see if you are into engines and motors, you definitely have a lot of experience talking and understanding how the ratios are needed in an engine with oxygen and fuel. But this is gasoline, so that's C8H18. So that's why you will hear things like octane uttered in terminology with gas, because there's 8 C's. It will always react with oxygen, and what it does is it makes CO2 and H2O. Well, that's called a combustion reaction. So if you've ever heard of like an internal combustion engine. Anything that basically explodes or starts on fire or it releases a ton of energy that is reacting with a hydrocarbon, fancy way of saying C's and H's, is a combustion reaction. Okay? So let me show you. I love doing this in the summer. I like going around and taking pictures of people's grills. Okay. I like grilling. And it's a propane tank. They always chase me out. It's really weird. I'm like, no, you just keep going. I like what you're showing me. This is a propane grill. So I take the propane, and now check it out. All 3 are exactly the same as above. The only thing that was different, instead of basically gas, I have a different kind of fuel, which is propane. You actually balance this. Hopefully you did already, in your balancing equation worksheet. I think I already said it once, but if I didn't, when I'm balancing something, you have choices. I think that's the biggest thing I heard in the last 2 days. Like, I don't know where to start. If you have an element the same in multiple places on one side, I don't want to touch those. So O's are my last step. So everything else then really becomes clear. I have 3 C's. I put a 3. I have 8 H's. I have a 2. I need to put a 4. And because of the 3 times 2 and the 4 times 1, I need to put a 5. So this is very basic, but it gives us the ideas of how to predict. And I'm going to show you how we're going to apply it in real time. I'm going to be doing 3 demos today that really kind of show us how we can figure out what is made, how it's used, all that good stuff. And it's going to evolve very quickly on us. But to help you out, we are offering a little extra credit by Friday. So if you'd like to read that, if that relates to you, you have time. You can get things in early. What we are offering is that you could, just focus on one equation. And the more effort and the better it looks, the nicer it is, the more creative it is, the more points you can get. You can get up to 15 potentially. You can make an extra credit poster. So if you want to make any kind of note. So I have some on here. Like, look at this one. Look at this penguin. He's wearing a hat. Look at that. And then that pig, he's got glasses on. But then, look, now he has the glasses, and the pig's wearing the hat.
Oh, wow.
What is that, though? What type of reaction? Double replacement. The rules. You need to make something. Well, do I have to draw it? No. You could find images on Google or whatever, but it has to be still made by you. I mean, there are posters out there. Like I saw one with Selena and the Biebs, and they're holding hands, and then someone else, I don't know if one of them, if he dated Taylor Swift. It looked like it was really hard to read. Did he date Taylor Swift? Okay, if you don't know, then I don't know. Oh, that was almost embarrassing. Well, it was another couple, and apparently those 2 dated those 2, and then there was new dating. So they had the new images. Great. If you want to and you can do it on your tablet and submit it if you like. You can draw on your tablet if you like. You can, again, find pictures of people, of things, or you can draw them yourselves. Here I have this one. This is a decomposition. It goes from an egg to a broken egg and a really big baby turtle, apparently. But those are some examples. So you'll draw it out or have it on there, and you'll put a title. That's it. That's all you have to do. Maximum size, 2 pieces of paper side to side. I'm not wanting some presentation where it's like the folded boards, you know, and then you pull out like this like laser stick, and you're like, all right, let me begin. Like we don't want that. Like, keep it small. But it's by Friday. It's not a lot of effort, but I'll say now, like these are little things that I'm always amazed people pass up. Be like, well, I'm doing great right now, right? My grade's good. It's like, but we haven't really done anything yet. So let's go. Let's get as much as we can. So it's your choice, but by Friday. If you're sick on Friday, guess what? You can upload it into Canvas. It's such a weird thing. I don't know how it goes on the line, but it goes in from the intern. Okay, so any questions though, what is required? Only one. I don't want to see 5 reactions. I want to see 1 type of reaction with the title of that reaction. And don't call it the baby turtle reaction. It would be decomposition. I've had that handed in once. Like they titled what they were doing. I'm like, that's not what we're doing. Okay, so do Friday, do Friday, do Friday, do Friday. Let's get out this sheet, please, the one that is landscaped. That looks like types of reactions, and there's 4 data tables in the back. Let's get that out, please.
Yes, we do.
Okay, so on the back, there are 4 reactions. These 4 reactions you will be doing on Friday. In the front, there are titles of each one. It says reaction A, reaction B, reaction C, reaction D. That is the procedure of each one. So it tells you. On the front, if you look, there should be like a tennis ball on fire or something like that, like a weird flame. There are 3 little mini procedures on the left. In the lower right, there is a data table. It says pre-lab 1, pre-lab 2, pre-lab 3. We're going to fill out those 3 today. And by filling those out, you're going to understand how to fill yours out on Friday. So please make sure you're staying with me. We're going to have some fun doing this, but we want to make sure that we're understanding this. So when it's written like this, we're going to underline and kind of give you a heads up of what I'm reacting with, what are my reactants, what are my products, and things like that. Please understand, we need states as well. So I'm going to write the reactants, the products, any observations, and the type of reaction. So we're going to do that together today. So first, it says mossy zinc. So I have some mossy zinc. What it is, basically molten zinc that like the drippings come off and then they dry and they're just all sorts of random shapes. Okay, so that's zinc. Well, I need the right, nothing's fancy or exciting about that, but that's one of my reactants. So, oops, be helpful if I have the ink. So I have zinc. What state of matter is that? Let's not overthink that. It's solid. Don't write M for metal. Oh my gosh. Then you're overthinking things. So that is solid. We don't need anything groundbreaking, but we need an observation. And I know this is a big room, so it's kind of hard to see, but it's kind of a dull silver. So I'm going to try to keep it under that one. So I'm going to write dull silver. Okay. And it says, placed into hydrochloric acid solution. Okay, hydrochloric acid solution. I got to remember that. Okay, hydro means that it's just H and one other element, so the chloric would be Cl. So I have HCl. What is a solution? And that's why I'm putting it up there, and it's good to talk about it right now. A liquid means that it's pure and only that thing. When we say solution, it means that something's dissolved in water. What was that other state? It was AQ. It was aqueous. So if you ever see the word solution, you have to write AQ. Now, again, not mind-blowing either, but it's just colorless. So I'm just going to write colorless underneath that one. Okay, so then we're going to give you some hints, and there's some cool ones that you're going to do. And some of you, if you're a little squeamish, you might want to have your partner be doing this on Friday. Don't want to scare you, but there's some excitement. It says if it is non-reactive to fire, it is chlorine gas. If it is reactive to fire, then it is hydrogen gas. Fill out the chart and you move forward. Before I go, what does this kind of look like? Like what type of reaction? You got 5 choices: synthesis, decomp, single replacement, double replacement, or combustion. What does it look like? I have something by itself. I have 2 elements here. That's a classic single replacement. So let's write that on the bottom line. Okay, so put the acid in. Put that in there. And I'm going to start to swirl. And it's not exciting in the beginning. The purpose is starting with this one first. But it has to get through the initial coating. You just gotta give it a second. And if you can, at least the people in the front, you can start seeing like the edge. What do you see just on the top surface? Bubbles, okay. So on the right side, a lot of times we're gonna write one of those 4 things: color change, gas or bubbles, heat or light, and or precipitate. I'll tell you now, it's starting to get warm too. So I'm going to write bubbles and hot, or heat, on this side. So those are just my observations. Bubbles. You can also write gas if you want to, but the whole point is, what are my observations that I'm saying this is actual chemical reaction? Now you can see I'm starting to collect a gas in here. And the more I swirl this, the more it's going to react. Now I want to get this as big as possible so we can test it. What we're going to do then is I'm going to tie this off, I'm going to tape it onto here, and I'm going to apply a flame. And if it just simply pops because it's a balloon, then I know that it's chlorine gas. So then that means that the chlorine got kicked out. If it explodes more than just a balloon popping, then I know that it's hydrogen gas, because then the hydrogen gets kicked out. Okay? Now you might be able to predict, because certain compounds replace similar compounds in charge, but we'll see for sure. And I am really hoping that this gets as large as possible, just so that we have the best chance of seeing what happens here. So just give it a second more, and then we'll go with it. So just... Okay. I'm going to mute it. I'll give it some time. We'll get this as dark as possible. Okay. I got my boomstick ready to go. Got my tape. All right, that's pretty good. Come on. Yeah, it's getting hot. Okay, we'll just go with that. I always like to go as big as possible. We got 20 minutes. Okay. Here we go. That's not the pop.
There you go. Yeah.
Shoot. Okay, hold on. I just lost some.
Good job, Mr. Wilson.
Sorry. Get some back in there. Still reacting, so that's good. Okay, that's about as good as we're going to do. I don't want to run out of time because we got 2 other really cool ones. Oh, there's more coming in. There we go. Okay. Let's try this again. Okay, perfect. Tape. Tape it to the top. Tape it to the top. Here we go. Here we go. I won't do it until... All right. Okay, so I don't know about you, but that's not the normal balloon pop that I'm used to. So that was obviously what? Hydrogen gas. Okay, so we have hydrogen. So now the zinc goes in where the hydrogen came out. So if the chlorine came out, the zinc would have gone in the second half. The hydrogen's coming out, so the zinc's going in the first half. And we'll talk about both quickly here. So it looks like that. Two things to talk about, and this is what this whole chapter is about. When I'm making new things, you have two things to process. If it's by itself, is it a diatomic? And I didn't even ask that about the zinc. Well, we learned, and you might have other sentences as well, but it's hexahalogens. That's not one of them. It's not HNO or halogen. So that's not a diatomic. Is that a diatomic? Yes. HN or O and a diatomic and halogens. So that is definitely H2. Okay? And then I already told you it was, but it's obvious that that was a, what state of matter? It's a gas, so we write G. The other one's a little confusing. So think of it this way. You're kicking something out, so you're going into it. So this is an aqueous solution, so this will be an aqueous solution. Before we write that, hold on. Every time I make a new compound, I got to check the charges. So zinc, it's one that we had to have memorized, unfortunately, but it's in group 12, so it's 2 plus. Chlorine, if you look at the periodic table, it's 1 minus. So every time I make a new compound, I check my charges. It's ZnCl2. And it's AQ. And then, like a lot of these, guys, the balancing should be pretty straightforward. What do I see? I see the Cl or the H, you can pick either one, is not balanced. If I put a 2 there, it ends up balancing both. And that is the end of that first one. So I have labeled, I have made my products, I've made my reactants, and I have done states of matter, observations, and type of reaction, all in that time. All right? All right, let's move to the next one. Hopefully you have that all down. Okay, here we go. It says liquid methanol. Might as well write down everything that it tells me right away. So that's liquid. Okay. It says is placed in a large water jug. I have one in my pocket. And it's filled with oxygen gas. Every time I write something by itself, I have to ask myself, is it a diatomic? Is oxygen a diatomic? Yes. Yes. And that's a gas. Okay. And exposed to heat. What did we learn on Monday? What do I do with that? I can write the word heat or little triangle on the top of my arrow. So I don't have a lot of room, so I'm just going to do the triangle. Before I go, I want to already ask, what type of reaction is this? So look at this. I have a height, don't worry about that O. I have carbons and hydrogens reacting with oxygen. And I'm going to add heat to it. Is this a decomp, a synthesis, a single, double replacement, or a combustion? Which one does this sound like? Combustion. Why I recognize that is carbons and hydrogens reacting with oxygen. So the minute I recognize that, the same two products are always made. CO2 and H2O. Every single time. I don't know the states of matter yet. We'll talk about that later. So this is combustion. This is the liquid. It's just colorless. There's nothing to say. And I'm not even going to talk about oxygen. I like it. I could write, no, don't write that. It's good. So what you have to do for this one is you pour the liquid in, and then you have to spread it out. And the reason why you want to spread it out is that you want it to evaporate. So I'm trying to increase the surface area, so if I keep moving it around, it just spreads out and I fill this whole container with a flammable gas. I'll keep doing that. Hold on. right, that's probably good. Dump out the excess. Meet the monitors. And I let my boomstick.
Whoa.
Yay. Hey. They call it the whoosh bottle. I'm still trying to figure out why. Oh. What do you think about that?
Good job.
So let's talk about states of matter. Oh, you're not zooming in on these. Mr. Neubauer, Mr. Blackford. You didn't zoom on any of these. Shoot. Okay. What's the water? I mean, H2O, it can be solid. I'm not expecting to pour ice out of here. Okay. Again, that would be a whole different class. That would be. So it's either gas or liquid. So that's definitely condensation. So that is a liquid. There probably is some gas as well. What is my CO2? It's got to be a gas. Anything else, that's really hard to have. So I need to have some sort of observation. So if you're not sure what to write for your products, you write evidence of a chemical reaction. So what did I see? I saw blue light, right? Like a lot of energy coming out of it. So blue flame, maybe? Bloom, what the heck am I writing? Blum? I can't erase it!
Bloom flame.
No! You can't spell blue.
Blum flame. Down that way. It's between plum and blue.
I had a blue plum today, that's why. Okay, so now you have to balance it. The problem is with this is that you have an O sitting in here. So if you're like, oh, I have 3 O's here and I have 3 O's here, that's great. I have 4 H's here and 2 H's here. So if I put a 2 here, that gets my H's balanced, but now I have 4 O's and now I have problems here. So if I put a 2 here, then I add the C's. So what I'd like you to do, it's going to take me a second to set up the next one. If you'd like, try to balance this, please, and let me know if anyone gets it. Okay? As I move on, I just need to set up a couple quick little things on the last one. Anybody get it?
Yeah, I think I got it.
What do you got from left to right?
2214.
2214?
Yeah.
No, it doesn't work. Because there'd be 2
so.
C's.
Oh, right, that's wrong.
What?
That doesn't work.
No, it doesn't.
2 C's.
Yeah, there's 2 C's.
But you got to have 2 C's.
Right, yeah,
Yeah.
there's not.
What'd you say? 2, 3, 2.
4.
3, 1, 2, or 1, 4.
2, 3, 2, 4.
2, 3. 2, 3, 2, 4.
It's not the 2.
No, it would work either.
No? 8, 14.
That's it.
Yeah, that works.
Because there's 8 H's and there's 4 H's here times 2.
Okay.
And there's 6 O's plus another 2 O's. That's 8 O's. 4 O's here, another 4 O's there. This is the first class that anybody had it, but from what I heard. Tell me. Everybody else has not gotten that right so far. Okay, so let's talk about the last one. It says ammonium dichromate is placed on a watch glass. So let's talk about that first. Now this is me thinking first, so don't write this yet if you don't want to. Guys, this is all about polyatomic ions, and some of you guys will shut down right away and not realize, well, if I use my polyatomic ion sheet, everything will work out. So ammonium is NH4+, dichromate is Cr2O7 2-. What do? My job is to crisscross charges. So it's just simply NH4. What do when I have polyatomic ion with a charge? I bring down that number with a parenthesis. And it says that it's a powder. So I'm going to guess that's a solid. We'll do observations in a second. Then it says heat is added. So I need to add some heat. Producing solid chromium 3 oxide. Okay, oh shoot, I got to figure out this one too. Okay, the 3 tells me the charge. 3 for charge, chromium oxide, so oxygen is 2-. So those crisscross. So I have Cr2O3. It told me that was a solid. Nitrogen gas, that's N. And water vapor. Whenever I write something by itself, I have to ask myself, is that a diatomic? Is N a diatomic? Yes, nitrogen is N2. Okay, we need to make some observations and things. So this is pretty sweet. You don't see this in nature too often, this color. This is very dangerous, extremely toxic. And it tastes just like it.
And you know how?
My kids tell me that tastes like Cheeto powder. I make them do it.
Oh, jeez.
So, bright orange on the bottom of the left side, that's definitely orange. If you're colorblind, it's orange. So, what we're going to do is we are going to make a little wick and put some ethanol on it. Okay. Bang! Heavy chemistry! Here we go. Takes a second to get going, so give it some time. Yes. That's not part of it, though. It makes random noises.
We just make.
Witchcraft.
Now, I'm going to turn on the lights and then quickly off. I want you to see what's happening. It's pretty crazy. I don't know why they call this the volcano reaction. I'm trying to figure that one out.
It's erupting.
Wow, this one's going a long time. So, you're like, whoa, how did they make more? It's not more, it's just less dense. So it looks like there's more. You can't make more or less of anything in a reaction. All right, so that's still, this is the longest. I think I put more in here than any other hour. So that's really dangerous right now still. We got to be careful with that. So what I do is I just rub it on your on your desks slowly, and it just disintegrates on desks really well during the year. Is he serious? All right. So, which one of the three products is the green? Think about states. This isn't a huge leap. The chromium, the nitrogen, or the hydrogen compound? Well, that's a gas, and that's a gas, so that has to be the green, right? This is orange. So what type of reaction is this, first off? It's green, trust me. I started with all of this, and now I have these. Synthesis, decomposition, single, double replacement, or combustion. Not combustion. Not double. Decomp. I started with one thing. Well, look at all those. Yeah, but it's one thing. And now I broke it into many. So this is a decomp. So, suggestion on balancing something like this. My eyes always go to something that's not normal, like not an H, C, or an O. So CRs look balanced. Okay, fine. N2. N2 is actually balanced. And my O's, because they're in multiple spots, I don't want to touch them. So I'm going to try to balance the only thing that's not balanced, which is the H's. So if I have 8 H's over there and 2 over here, and if I put a 4, check this out, I end up having 8 H's here, 4 O's plus another 3, that's 7. Look at that, that's 7. So it all works out. Balance and equate. So you're going to be doing 4 of these on Friday. By Friday, if you want to do an extra credit poster, you definitely can. Balance equations due today. Equations 1, which is small, and you've had it for a couple days now, that is due by tomorrow.